everyone, and welcome back to our next trigonometry lesson. And as I promised, we are still going to look at the cast concept. Now, it's quite an important concept in trigonometry, and we want to get this right, so that's why I spend another lesson on this, just so that I can show you a couple of more examples. And then there's a couple of things that I also want you to remember. The important thing is that we always want to work with our normal trigonometric functions. So they must be of the form sine of theta equal to a ratio, or the cosine of theta equal to a ratio, or the tangent of theta equal to a ratio, or any other angle there, okay? But we do not want the coefficient at the front or any other constant here, +3 or +2, no. We just want the function equal to a ratio, because then if we just have the function written like this, we can find it on the Cartesian plane and we can draw our triangle, because we know the sine of theta is equal to a ratio of two sides, right? So is the cosine of theta and the tangent of theta. Can you still remember which sides are the ratios for the sine and the cosine and the tangent? Well, you should. So here we go. If these functions are not in this normal form, for example, like here, it says 13 cosine beta minus 5 equals 0. That's not just a cosine beta standing on that side. So we have to move the constant and we have to divide with that coefficient so that there's just a cosine beta. That's what I mean here, okay? Then another thing to remember is that any function squared and then the angle means exactly the same as that function with the angle in brackets and then squared, okay? So when we work with the ratio instead of the cosine of the angle, we want to put it in brackets and then square it. And you'll see an example like that as well here. So let us see how we will solve the following ones. We are given 13 cosine beta minus 5 equals 0. And we are given the following info that beta is greater and equal to 180 degrees and less than equal to 360 degrees. Determined by means of a diagram, so we cannot use our calculator, the sine squared of beta plus the cosine squared of beta. Okay, so the first thing I want to do is, we know that we do not have a normal function. We've got 13 cosine beta minus 5 equals 0. So we want to rewrite that first. And we do this here on the side. So we are just simply going to take the 13 cosine of beta, and I'm going to move that minus 5 to the other side, and then it becomes a plus 5. Got it? Okay, still not done, because I don't only have the cosine of beta. We want it to look just like that. So we have to move that 13. So the cosine of beta is equal to a positive 5 divided by 13. Okay, so there we go. So basically, the cosine of beta is a positive ratio, right? Okay, so now I quickly go and draw a small Cartesian plane like this with our cast in it, just to make sure that I want to know where this cosine beta is actually on this Cartesian plane. So the cosine beta is a positive ratio. So it can either be in the fourth quadrant or in the first quadrant, right? But now we cannot draw a triangle in both of these quadrants. We have to eliminate another one so that we only find one quadrant. So beta is greater than 180 but less than 360. So it's somewhere there, okay? We know it cannot be there, and it cannot be there already. And then we also know it won't be there because beta is over here. So let me just quickly write that in slow motion for you. So from this cosine beta is positive, we get the information that we are either in this quadrant or in this quadrant, right? Okay, so those two are eliminated. I'll cross them out. There we go. And then we know that beta is between 180 and 360. So it's somewhere there, okay? So it won't be that one. So where are we now? In the fourth quadrant. Okay, so I bring in my Cartesian plane like this, and then I go and draw in my triangle. We know it's in the fourth quadrant like this, and then we draw it up like that, so it's 90. And then basically we already have the ratio of the sides, and this angle there will be beta. So let's draw in that angle. That's beta. So there's my angle. And then if we look at it from this side, That's my adjacent. This is my hypotenuse, so it's 5 over 13. So look very closely. It's 5 there and 13 here. And just make sure about their signs. The hypotenuse is always positive. The x there will always be positive because this is the x values to the right of my y-axis, right? Okay, we need to find the missing side here. So therefore, we are going to have to calculate it with Pythagoras. And we call this one our y. So basically, the y squared is equal to my hypotenuse squared minus our base squared, which is 5 squared. And then we have 169 minus 25 is our y squared. So y squared is equal to 144. We square root this, square root that side, and y equals a plus or minus 12. Now, it's up to us to go and make sure if it's a positive 12 or a negative 12. And look at the y, it's below our x-axis, so it will be a negative 12. And I'll write that in red. So y is equal to a negative 12. And there's my 3 sides. From here, we can work out any ratio that has the angle beta. So they want us to calculate the sine squared of beta plus the cosine squared of beta. But I'm first going to rewrite that ratio, which is in that form, or this function that is in that form, into that form, so I can easily work with my ratios. So again, look very closely. I'm just going to write this as the sine of beta squared plus the cosine of beta in brackets squared. Now I just go and find the sine of beta. Well, the sine of beta will be my opposite over my hypotenuse, which is minus 12 over 13. So let me go write that in. It's minus 12 over 13, and then we have to square it. And then plus, what is the cosine of beta? We don't have to look that far. We know it's the adjacent over the hypotenuse, and we already know it from there, right? Which is 5 over 13, and we also square it. Now, even though this ratio is negative, when we square a negative sign, it becomes positive. So this will basically be 144 over 169 plus 25 over 169. And then if you use your calculator, or if you just want to do it out of your head, because the denominators are the same, it will stay 169. And then 144 plus 25 is 169. My answer is 1. Okay, and there we go. We didn't even have to use a calculator. Now the next question says that we have to find the sine of beta plus the cosine of beta. Well, we will have the 3 sides for a triangle where the angle is beta, so we can get the sine of beta. It will be my opposite side over my hypotenuse, so that will basically be minus 12 divided by 13, and it's in brackets plus the cosine of beta. We already know it's 5 over 13, and then we need to square it, right? So this is equal to, and the denominator will stay at 13 because they're the same even though we're adding. So it's just minus 12 plus 5, and that gives us a minus 7. And there we go, and then we need to square it, and that equals to 49 over 169. There we go. So do you see, it's really not that hard. Now in the next part of this video, we are going to look at another type of example which is also quite important. Now in this example, there are no numerical values, okay? And what I mean by that is that we are given the sine of beta, but it's equal to p, no numbers, okay? So the ratio is actually not given as numbers, but as a letter. And they really love these examples in the exam. Now you will find this just as easy as the previous ones because we do it exactly the same way. Okay, so let's determine the cosine squared of beta with a diagram if we are given the following information that I'm circling here with my arrow. So the first thing that we need to do is I'm going to write down here the sine of beta just so you know what it means. The sine of beta is equal to p. Now, so we are given the normal trigonometric function just the way we like it, and it's equal to p. The sine of an angle always is the ratio of the opposite side over our hypotenuse. Now, P can also be written as P over 1. So basically we have the opposite side and we have the hypotenuse. There's our ratio, okay? So nothing is different. And this ratio is also positive. So if I quickly draw my Cartesian plane and I write in cast like this, we know that it's positive, the sine of beta, so it will either be in this quadrant or it will be in that quadrant, right? Okay, now what other information? Beta is between 90 degrees and 180. There's 90, there's 180. So we know that beta is somewhere there. So it won't be there, it won't be there because here the sign is negative, there the sign is negative. So it can only be in the second quadrant, right? Okay, great. So what I do now is I draw in my Cartesian plane like this. And we know that it's in the second quadrant. So I draw my hypotenuse from the origin all the way up. And then I can draw that line down like this. And we know that this angle here is beta. Okay, so when we look at this triangle from beta side, okay, from here, we know that this is our opposite, that's the hypotenuse, this will be our adjacent. And the sine of beta is the opposite over our hypotenuse, so there's our opposite. So that side there will be our P, there we go. This is our hypotenuse and the one here at the bottom is still missing. And we can actually go and calculate it because with any right angle triangle, we can calculate a missing side if we have two of the sides already. Okay, so we are going to calculate this x. And let's quickly go and see what the answer will be there. So we are going to make use of Pythagoras and we will say that it will be our x squared is equal to our hypotenuse, which is 1 squared minus p squared, right? Because it's always our hypotenuse squared minus the height squared to get the base squared. And then what we do next is we are simply going to square root this x squared and then we're going to square root that. So then we end up with x equals the square root of 1 squared minus p squared. And look very carefully. So x is equal to, and then we know that we cannot subtract those, but we have to do our powers first and we can get the answer for 1 squared. 1 squared is just a 1. So it will be 1 minus p squared. And there we go. So basically our x is 1 minus p squared in a square root. And then I'll write this down in red. So we know that this answer here is actually the square root of 1 minus p squared. Okay, so this side is 1 minus p squared in a square root. But now again, be careful. Where is this triangle? It's in the second quadrant. So this x value needs to be negative. So this answer here must also be negative because, and I'll run up back here, just to show you that when we get a square root of any number and whatever this number might be, we will get a plus or minus answer. And in this case, depending on where it is in the Cartesian plane, we're going to use the negative value because the x values are negative. So we've got a minus square root of 1 minus p squared. Okay, great. So now we just have to solve for the cosine squared of beta. Now you know from before that we rewrite that cosine squared of beta as the following. We will say that it's the same as the cosine of beta in brackets squared, and then we simply go and find the cosine of beta. There's beta and we've got the three sides, so it will be the adjacent over the hypotenuse. So that will basically equal to, what is my adjacent? It's minus the square root of 1 minus p squared over 1, which is then put in brackets, right? And that is exactly the same as minus the square root of 1 minus p squared in brackets squared. And then you will see that the answer will then be, if we square root or square the minus, it will be a positive. If we square a square root, the square root will just fall away, and my answer is 1 minus p squared. And that's it. Okay, so great. So can you see the little bit of algebra that is in here? But we solve this example exactly the same way as before. We want to know where the sine of beta, where that triangle is on the Cartesian plane by following these clues. The ratio is positive, so it's either in the positive quadrants, and then they tell us beta is between 90 and 180, so we ended up in the second quadrant. We draw in the triangle, we put in the ratio of the sides that we have, and we find the missing side, and then we can calculate the cosine, the tangent, and the sine of beta. As easy as that. Okay, so again, I hope to see you again soon, and keep practicing. Bye! This is your host Richard T, and thank you for joining us. Please visit our website mathsa.co.za for free guided exam tutorials.